In this session, we will see about full subtractor. A full subtractor is a device having 3 inputs. So, this is full subtractor. We will be having 3 inputs A, B and B in, borrow in. And it produces 2 output, namely the difference. D is the difference and a borrow out. So, we will see the truth table first. So, this is the truth table. The first session is the input, first part is the inputs A, B and borrow in, and the second part is the output, we have D and borrow out. So, we will try the different combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So, these are the different input combinations with 3 bit. Now, we will see the outputs for each different type of or different combinations of input. The first one, 0 minus 0 is 0, that resulted 0 with B in. When we subtract that 0 minus 0, again it is 0. So, first 0 minus 0 is 0 and this 0 minus this 0 is 0. So, the final answer is 0. So, therefore, the difference is 0. We haven't borrowed anything when we do this 0 minus 0 and again 0 minus 0. So, borrow out is also 0. The next case, first 0 minus 0 is equal to 0. Now, this 0 minus 1, yes, we can do that, but it is smaller number minus larger number, 0 minus 0. We can do that with a borrow 1 as we do in decimal number system. So, we have a borrow 1 because in order to do 0 minus 1 we need a borrow and the difference is 1, 0 minus 1 difference is 1, actually it is negative 1. Same the case of decimal and binary, actually in binary there is no negative 1, in decimal it is 0 minus 1, the difference is 1, difference between 0 and 1 is 1, we will say it as negative 1 in decimal number system. But in binary the 0 minus 1 the difference is 1, but if we want to do that we need to take a borrow from the previous bit. Now, the next case, starting 0 minus 1, just now we have seen that if you want to do 0 minus 1 we need a borrow. So, straight away we can put borrow 1. So, 0 minus 1 difference is 1. Now, this 1 minus next is 0, that is 1, 1 minus 0 is 1, there is no need of borrow for that. So, 1 minus 0 is 1. So, initially during the first case when we want to do 0 minus 1 we need a borrow, therefore, we have put borrow here. Now, the next case again 0 minus 1, if we need to do 0 minus 1 we need a borrow. 0 minus 1 the answer is 1. Now, this 1 minus next one, that is 1 minus 1, that is 0. So, the difference is 0, final difference is 0. Next case 1 minus 0 is 1, the resultant 1 minus 0 is 1. So, difference is 1, we haven't borrowed anything, so borrow out is 0. Next 1 minus 0 is 1 and this 1 minus next one is 0. Next 1 minus 1 is 0, then 0 minus 0 is 0 with a borrow 0. Next finally 1 minus 1 is equal to 0. Now, this 0 minus 1 we need a borrow, since 0 minus 1 difference is 1. So, this is the final table. Now, we need to find the equations for D and B. We need to find what is D and what is B out. First we will see what is, or we will find what is D. So in order to find that, we will draw the K-map. Since input comprises of 3 variable, we need 3 variable K-map. So we will draw the 3 variable K-map. We have A, B, Bn 0 0 0 1 1 1 1 0 0 1. So we will see where and all we can place 1. First case is here, D is 1 in this case, 0 0 1. Here D is 1. Then D is 1 in 0 1 0, A0, B1 and B in 0. That is which cell? Last cell. Then 1 0 0. Then 1 1 1. These are the 4 cells. So there is no way we can combine 2 cells. Each one have to group individually. We cannot combine. So the final equation is for D is equal to equation for each cell. This is A bar, B bar, Bn. This is A, B bar, B in bar. This is A, B, Bn. And finally this is A bar, B, B in bar. So if we add all these, you get the expression for difference is equal to, we will add all these, A, B bar, B in bar plus A bar, B, B in bar plus A bar, B bar, B in plus A, B, B in. Now first take the first 2 term, consider the first 2 term and take B in bar as common. You will get A, B bar plus A bar B. And in the last 2 term, consider B in common. So plus you will get A bar, B bar plus AB into B. Now this is equal to, what is A B bar plus A bar B? A XOR B. So I have written it like this, and we have to write into B in bar. So into B in bar plus, now what is A bar B bar plus AB? A XOR B, that is A XOR B the whole bar into this B in. Now as in the case of full adder, let A XOR B is equal to P. Therefore, we can write, this equation will become P B in bar plus, this will become P bar B in. So what is P B in bar plus P bar B in? This is of the form A B bar plus A bar B, that is A XOR B. So we have, this implies P XOR B in bar. Now what is P? That is, substitute for P. P is, it is written here, P is A XOR B. So we have substituted. Now write B in bar also. B in bar, sorry, XOR B in bar. P is A XOR B and XOR B in. So previously I have written B in bar, there is none of B in bar, just P XOR B, because A B bar plus A bar B is A XOR B. Therefore, P B in bar plus P bar B in is P XOR B. So this is the final answer for our difference. So we got difference D is equal to A XOR B XOR B in. This is our difference. Now in the same way we have to find the borrow out also. We will see. We want to see or we want to find B out. Again we have to draw 3 variable K map because we have 3 input variables. So they are A, B, B in 0 0 0 1 1 1 1 0 0 1. So we will check where is, in which cases and all B out is 1. So first case is this 0 0 1. This is 1. Second case, this is B out 1, that is 0 1 0. This is 1. Now third case is this one 0 1 1, and here it is 1, and last case is 1 1 1. Here there is B out is 1. So if we group this, first group, when I group this one, we can take this as a group. Now the second group, this is another group, and finally the third group, this is another group. So these are the 3 groups, and this value of this blue group, light blue group, is B in, and value of the dark blue group is A bar B, and the value of the yellow group is A bar B in, A bar B in. Now if we add all this, we get B out is equal to A bar B in plus B in plus A bar B. So this is the final equation for borrow out. So you got B out is equal to A bar B plus A bar B in plus B in, or we can, let me check, is there any mistake? This is A bar B in, this is A bar B, and this is B in. Yeah, correct. Or we can take common also. We can take it as A bar B into, A bar B in plus A bar plus B into B in. This is also okay. Now finally we have to draw the equation, logic diagram. So we have A, we have B, and we have the third input is B in. Now first we will draw the diagram for D. D is A XOR B XOR B in. So we need to XOR all these. So this is D, difference, that's equal to A XOR B XOR B. You can use two XOR gate also. First XOR gate will perform the XOR operation with A and B, and the resultant will be XORed with B. Now the second one, we have to draw the diagram for B out. So for B out, first we will find A bar B. So we will take A and invert it. So you get A bar, and we also take B. Now we will add it. So here you have A bar B. Now we want to add A bar plus B. So A bar is here, A bar, and B is given to OR gate. So you have A bar plus B, and this A bar plus B is multiplied with B in. So take B in and A bar plus B, this is given to AND gate. So you will have now A bar plus B multiplied by B in. Now both these are added together, both A bar B and A bar plus B into B in are added. That means OR gate. So this is B out, and this is the logic diagram. So for full subtractor, we have discussed first the logic symbol. This is the logic symbol. Then we have discussed the truth table. Then we have discussed the derivation of difference and borrow out. That means derivation for these outputs with respect to inputs. So we have found the difference, and then we have found the borrow, and finally we have drawn the logic diagram.